Alright, you guys, we're going to look at the paired t-test now. And if you're in your week 5 R project, then you can open the week 5 paired RMD file, and it's going to add another tab up here with your paired data. And if you already went through the independent t-test video, then you installed the JSQ package, the StatCat, more tests, and Walrus packages in Jamovi. I'm going to go ahead and open Jamovi up. And I already have those packages installed. So now we're going to look at the invisibility.sav file, and I believe that is a SPSS data file. So we're going to go over here to the 3 little lines. I think that's like the file menu. We're going to say open. I'm going to browse and go to my week 5 assignment, and we're looking for invisibility RM save. So I'm gonna, and that stands for invisibility repeated measures save. And field discusses a little more what this is. So I believe in the independent version, he had 2 groups. One group had an invisibility cloak and one didn't, and they were looking at the number of mischievous acts. And in this one, it's related, and what they did is they measured people when they had no cloak, and then they gave them a cloak, and then they measured people after they had a cloak. So it's the same participant at 2 different time points, and that's why we're going to look at a paired t-test, because it's the same individuals. The observations are no longer independent. So what is the level of measurement for cloak and no cloak? And these are both counts of the number of mischievous acts, and they're split into 2 different variables, and so I would call that ratio level of measurement, because 0 means 0, so it has a ratio level. And if we go look, indeed this one is no cloak is set up as continuous, and cloak is also set up as continuous, and so we look good that way. Next, we're going to look at making sure that we don't have any problems. We're going to follow the steps that we have been going over all semester. First, looking at some data accuracy, looking for missing data, outliers, and so we're going to get descriptive statistics. So we're going to go into Jamovi and into exploration and descriptives, and before we do that, we should one thing that we need to do is calculate the difference between the 2 scores, because when the paired t-test, we're looking at normality of the differences. So I'm going to go back into data, and we're going to click on a new variable, and we're actually going to do a new computed variable. So I'm going to call this difference, and the formula is going to be see, I did this once a long time ago. Just make these so I can see them. And okay, I think we need to type in okay. So the name of the first variable minus the name of the other variable, and hit formula, and then we can see that we got different scores between those two. So that worked. Now we can go get our descriptive statistics. And we didn't end up using that one, and I'm just going to right click on it and hit remove. So now we're back here in descriptives, and we're not really going to, so we want to look at our you just look at all three variables. We got the mean, standard deviation, variance. What else did I ask you guys to get? Mean, median, standard deviation, variance, range, minimum, maximum, skewness, kurtosis, Shapiro-Wilk. Skewness, kurtosis, Shapiro-Wilk, the range. Okay, so we can see we have means for cloak and no cloak. Those are the same as we had last time. The difference, we'd seen that on the independent t-test, so that's the difference between the two. Median on the difference, standard deviation, and variance. Remember, the standard deviation is just the square root of the variance, so those numbers are, a lot of statisticians just consider those interchangeable because it's easy to convert from one to the other. We have a range from the low to the high, so in the differences there's only a 4-point difference. Skewness and standard error of the skewness, so we see that we're at -5 and 0.6, which is less than 2, so we're not going to worry about non-normality assumption, and if we check our Shapiro-Wilk, not significant. So again, that's an indicator that our normality assumption is going to be met. So if we're going to check this, we can go into our, you can compare with the field text on our descriptives should all be very similar, and we're going to run a paired t-test. So now we can go to t-tests and paired samples t-test, and we're going to do no cloak and cloak and move those over. And I think we could have dragged them over independently, but that's pretty easy. Go ahead and get a Bayes factor, and we'll get our normality assumptions. We'll get descriptives and descriptives plots, mean difference, effect size, and a confidence interval. We'll go ahead and do get our non-parametric test. for a paired t-test, the non-parametric equivalent is a Wilcoxon signed rank test. Okay, so we have our test of normality. Again, the Shapiro-Wilk is not significant. Neither is the Kolmogorov-Smirnov, and Anderson-Darling isn't either. We have our descriptives, and this normality is well, that's looking at the difference. Okay, and we can see that no cloak is lower than cloak. We can see our standardized residuals, our QQ plot here falling pretty close to the normal line, so that indicates that we're okay. So we can interpret our output, and here's our student's T, and we can see our test statistic is negative 3.8. That's a T. I probably would have preferred it if they would have put a T here in this output. If you've been doing statistics a while, you would know that's a T, but if you're new, that may not be something you always remember. So that is a T statistic. And you'll see this is a lot higher with t-test. Usually if you hit about 2, just a shade over 2, it's going to be significant. And so that's definitely higher than we saw last time. And you'll see that our p-value is 0.003. So when we are looking at paired values, they're a lot more powerful than independent observations. And so our p-value is significant. There is a significant difference here. So it really does make a difference if you're looking at paired data, related data, as opposed to independent data, because these numbers are all the same that they were in the last one, but we treated them as 2 independent groups as opposed to paired. And you'll see there's our mean difference, our lower and upper bounds of our confidence interval, so that's the standard error of the difference. You'll notice that our confidence interval on our mean difference, the lower bound is negative and the upper bound is negative. 0 does not appear within that confidence interval. So that means that there is a difference between the 2 groups. You'll also notice our Cohen's d is a lot bigger, negative 1.1 as opposed to 0.7 before. And so that's a large effect size. So I can stop pushing the wrong button. We can look at our descriptives and see that when they have a cloak, they did more mischievous acts than when they didn't. And the difference is significant. There's our plots. And where did my base factor? Oh, there's the base factor. So you'll see that this is the base factor of 1, 0, means that we're comparing the data. If the alternative hypothesis was true, over the probability of the data, if the null hypothesis was true. And this is much larger than 10, which is strong evidence that the alternative hypothesis, that there's a difference in the scores when they have a cloak compared to when they don't, is that difference is there. So the base factor kind of gives us the same information, and we would say there's strong evidence that we should accept the alternative hypothesis and reject the null. If we had a problem with normality, then we would conduct a Wilcoxon, and again, Jamovi is nice to us and groups the Wilcoxon signed ranks test there with the paired samples t-test. It does the same thing. It tests the same thing but using a non-parametric method. And we have a test statistic and a p-value, which is also significant. So all of the test statistics basically give us the same story along with our plot, that there's a difference there. If we were going to use a robust method, we could go into Walrus and pick a robust paired samples t-test, and again we would use cloak and no cloak, and we would look for mean differences, confidence interval, and effect size. And our robust paired samples t-test again gives a t-value that's bigger than 2, and our p-value is significant, 0.03, with a mean difference of 1 point. And our 95% confidence interval, the lower and the upper bounds are both negative, so 0 is not found within that confidence interval. There's a significant difference between the two. Cohen's d gives us a Cohen's d of almost 4, which is a medium effect size, using usual conventions with effect sizes. And if we went and looked at our Bayesian methods, and we picked a Bayesian paired sample t-test, again we would pick cloak and no cloak and move those over. We're going to test that group 1 is not equal to group 2. Keep the alternative over the null. Go ahead and get descriptives. Go ahead and get prior and posterior, a base factor robustness check, and descriptive plots, and exclude cases analysis by analysis. So here's our base factor of 16 again, which is strong evidence that we should accept the null hypothesis and or accept the alternative hypothesis and reject the null. There's strong evidence that that the alternative, that there's a difference between the groups, is there's evidence to support that hypothesis. Again, there's our same descriptive statistics, the mean and standard deviation for when they didn't have a cloak compared to when they did, and we can see that the cloak had more mischievous acts than the no cloak. And here's our base factor, again with the probability of our alternative hypothesis, the data given our alternative hypothesis compared to the probability of our data given the null hypothesis. You can see that null hypothesis is pretty small, so it's unlikely that that the null is true, and a lot more likely there that that there's a difference between the two. And you can see we have that same prior, which came from selecting our Cauchy. We didn't look at it, but it was that Cauchy distribution comparing two normal distributions, and we left it unchanged. And here is our posterior, showing that the effect size is down towards 1 and a lot more peaked. And we have that same robustness check. You'll see that if we'd picked a really narrow prior, that it's a lot smaller, but after you go much above 0.5, that the numbers stay pretty consistent. So the prior that we picked was this gray one here. the wide prior would be the black one, ultra wide would be the white one, and you'll see that it doesn't make a big difference no matter what we picked for our prior, so what we picked works just fine. That's what that robustness check is looking at. And again, there's the references down at the bottom. Let's see what else we were asking for on this assignment. So under StatCat, did we look at that? Oh, we forgot to put that in. Let's go ahead and just go to StatCat, and we're looking at relationships because we got a couple variables that we're looking at together. And oh, I picked the wrong one. So we want repeated measurements. So we can go to this one, right click, and remove it. We're on repeated measurements and related variables, cloak and no cloak. And you'll see it knows we have two numeric variables, and we're going to do a paired sample t-test. If the paired sample, we violated assumptions, then we'd use the Wilcoxon sign rank test. Just so you're aware, apparently this StatCat add-in, there is a website that's connected with that, and if you click on the tests, it will take you to this StatCat website, and you'll see it looked like to me, I think I looked at this briefly, and some kind of person that's taught statistics for a number of years has created this, and you'll see a nice alternative description of what a paired t-test is, the null and alternative hypotheses, and so it's pretty good. It's they're worth reading through, and there's even like some practice questions you can look at on these. So it's a pretty nice support tool for understanding how to select the right test. Okay. We looked at which tests were recommended there. We looked at our assumptions. Well, it looks like I did not remove that homogeneity variance assumption because they're related, so we don't need to worry about that one. But we still were looking at normality of our different scores. We ran our t-test, and we didn't violate any assumptions, so we were good to run our paired t-test. We ran our walrus and our Bayesian paired t-test, and we want to report the paired t-test information. So if we go back up to our paired t-test, then we would get our information from the student's t-test, and we could get descriptives either from the descriptives that we ran at first or from the descriptives table that came with the test. Okay, so we can save this output. We'll go up here and do save as and browse to make sure we're going to be in the right folder, and we can call this our paired t-test output and save it. And we can also knit our file there, and there's our week 5 paired and let's make sure I found it. That's the original. Where did it stick it? Oh, okay, there it is right there, week 5 paired. That's what we would go turn in. All right, and I will see you guys in office hours.